So now that you know all about backend development, it's time to dive really deep into how Node.js actually works behind the scenes. So you're gonna learn all about the Node.js architecture, events and the event loop, streams, modules, and more. And the kind of knowledge that you will gain from these videos will really set you apart from other Node developers out there. And that is the whole reason why I always include these kind of more theory lectures into my courses. Now, most people absolutely love them, but some students just want to write code as fast as possible, which also kind of makes sense. But no matter how you feel about theory lectures, I invite you to at least try out some of them. And this is actually more of a mix of theory and code lectures, so that you can immediately apply what you learn. Anyway, I'm actually really happy with the quality of this content and also really excited about sharing this with you now. So again, I'm sure that this kind of content can absolutely give you a competitive edge over some other junior Node developers. Now, in order to set the stage for the next couple of lectures, let's start by learning a bit about the Node architecture. So let's represent that architecture here in terms of Node's dependencies, which are just a couple of libraries that Node depends on in order to work properly. So the Node runtime has several dependencies, and the most important ones are the V8 JavaScript engine and libuv. Now, we said before that Node is a JavaScript runtime based on Google's V8 engine, right? And so that's why it appears here as a dependency. If it wasn't for V8, Node would have absolutely no way of understanding the JavaScript code that we write. And therefore, V8 is a fundamental part in the Node architecture. So again, the V8 engine is what converts JavaScript code into machine code that a computer can actually understand. Okay, but that alone is not enough to create a whole server-side framework like Node. And so that is why we also have libuv in Node. And libuv is an open source library with a strong focus on asynchronous I/O, so input-output. This layer is what gives Node access to the underlying computer operating system, file system, networking, and more. Besides that, libuv also implements two extremely important features of Node.js, which are the event loop and also the thread pool. And in simple terms, the event loop is responsible for handling easy tasks like executing callbacks and network I/O, while the thread pool is for more heavy work like file access or compression or something like that. But you'll learn all about that, so about the event loop and the thread pool, in the next couple of videos. One important thing to note here is that libuv is actually completely written in C++ and not in JavaScript. And V8 itself also uses C++ code besides JavaScript. So therefore, Node itself is a program written in C++ and JavaScript, and not just in JavaScript as you might expect, right? Now the beauty of this is that Node.js ties all these libraries together, no matter if written in C++ or JavaScript, and then gives us developers access to their functions in pure JavaScript. So it really provides us with a very nice layer of abstraction in order to make our lives a lot easier, instead of us like having to mess with C++ code. That would be a terrible experience, right? So again, this architecture allows us to write 100% pure JavaScript code running in Node.js and still access functions like for file reading, which behind the scenes are actually implemented in libuv or other libraries in the C++ language. And speaking of other libraries, Node does actually not only rely on V8 and libuv, but also on HTTP parser for parsing HTTP, CARES or something like that for some DNS request stuff, OpenSSL for cryptography, and also zlib for compression. And these are not that important to understand, alright? So in the end, when we have all these pieces nicely fit together, we end up with Node.js ready to be used on the server side of our applications. And next up, you will learn more about threads in Node and the thread pool, so stay tuned for that one. So remember that in the last lecture, we talked about the node architecture, where two fundamental parts are the thread pool and the event loop. So in this lecture, you're going to learn all about threads and the thread pool, and in the next one, we will then dive deep into the event loop. So let's get started. So first off, when we use Node on a computer, it means that there is a Node process running on that computer. And a process is just a program in execution. And we already learned that Node.js is basically a C++ program, which will therefore start a process when it's running. This is important because in Node, we actually have access to a process variable, which we're going to use later in this course. Now, in that process, Node.js runs in a so-called single thread. And a thread is basically just a sequence of instructions. But it's not important to deeply understand what a thread or a process is. That is more about computer science. Just imagine a thread as being a box where our code is executed in a computer's processor, alright? Now, what is important to understand here is the fact that Node runs in just one thread, which makes it easy to block Node applications. And this is something that we talked about before, actually, but it's something really, really important to remember, because this is one of the unique features that Node.js brings to the table. So again, if you run your Node application, it will run in just a single thread, no matter if you have 10 users or 10 million users accessing your application at the same time. And so you need to be very careful about not blocking that thread. And we will of course take care of that throughout the projects in this course, okay? Moving on, let's now quickly understand exactly what happens in a single thread when you start your Node application. So when the program is initialized, all the top-level code is executed, which means all the code that is not inside any callback function, okay? Also, all the modules that your app needs are required, and all the callbacks are registered, just like the ones that we used for our HTTP server in the Node Farm app. Remember that? Then, after all that, the event loop finally starts running. And again, more about the event loop in the next video. What you need to know for now is that the event loop is where most of the work is done in your app. So it's really the heart of the entire Node architecture. But here is the catch. Some tasks are actually too heavy. They are too expensive to be executed in the event loop, because they would then block the single thread. And so that's where the thread pool comes in, which, just like the event loop, is provided to Node.js by the libuv library that we talked about before. So the thread pool gives us 4 additional threads that are completely separate from the main single thread. And we can actually configure it up to 128 threads, but usually these 4 are enough. So these threads together form the thread pool, and the event loop can then automatically offload heavy tasks to the thread pool. And all this happens automatically behind the scenes. It's not us developers who decide what goes to the thread pool and what doesn't, alright? Now, the expensive tasks that do get offloaded are all operations dealing with files, everything related to cryptography, like hashing passwords, then all compression stuff, and also DNS lookups, which basically matches web domains to their corresponding real IP addresses. So this is the stuff that would most easily block the main thread. And so Node takes care of automatically offloading them into the thread pool, where they don't block our event loop. And that is the most important thing that I want you to retain from this video, alright? So let's now move on and talk about the event loop itself. Welcome back. Let's now learn all about the event loop, which is the heart of the Node.js architecture. And this is probably the most important lecture in this section, so make sure you really understand everything that I show you during this video. So let's get started. So here's a diagram similar to the last lecture, so that we know exactly what we're talking about here. So we're still in a node process in a single thread where the event loop runs, all right? Now, the first thing that you need to know is that the event loop is where all the application code that is inside callback functions is executed. So basically all code that is not top-level code will run in the event loop. Some parts might get offloaded to the thread pool, as we saw in the last lecture, but it's the event loop that takes care of all this. As I said before, it really is the heart of the node architecture. Okay, now as I mentioned many times in the first part of the course, Node.js is all built around callback functions. So functions that are called as soon as some work is finished, sometime in the future. Remember that? And it works this way because Node uses an event-driven architecture, which is something that we're going to talk about in one of the next videos. But what you need to know for now is that things like our application receiving an HTTP request on our server, or a timer expiring, or a file finishing to read, all these will emit events as soon as they are done with their work. And our event loop will then pick up these events and call the callback functions that are associated with each event. Okay, makes sense? So again, the event loop receives events each time something important happens, and will then call the necessary callbacks such as we define in our code. So in summary, it's usually said that the event loop does the orchestration, which simply means that it receives events, calls their callback functions, and offloads the more expensive tasks to the thread pool. Now, how does all this actually work behind the scene? In what order are these callbacks executed? Well, that is what we're going to find out next. So remember, when we start our Node application, the event loop starts running right away. Now, the event loop has multiple phases, and each phase has a callback queue, which are the callbacks coming from the events that the event loop receives, just as we talked about in the last slide. Now, in some places, you will read that there is only one callback queue or one event queue, but in fact, as I said, the event loop has many phases, where each phase has its own callback queue. So let's now take a look at the 4 most important phases. There are 1 or 2 other phases that are used internally by Node, but these are not that important, and I'm not going to talk about them. So the first phase takes care of callbacks of expired timers, for example, from the setTimeout function. So if there are callback functions from timers that just expired, these are the first ones to be processed by the event loop. If a timer expires later, during the time when one of the other phases are being processed, well, then the callback of that timer will only be called as soon as the event loop comes back to this first phase. Make sense? And it works like this in all 4 phases. So callbacks in each queue are processed one by one until there are no ones left in the queue, and only then the event loop will enter the next phase. Next up, we have I/O polling and execution of I/O callbacks. And again, remember that I/O stands for input-output. So polling basically means looking for new I/O events that are ready to be processed and putting them into the callback queue. And remember that in the context of a Node application, I/O means mainly stuff like networking and file access. And so it's in this phase where probably 99% of our code gets executed, simply because in a typical Node app, the bulk of what we need to do is related to networking and also file accessing. The next phase is for setImmediate callbacks. And setImmediate is a special kind of timer that we can use if we want to process callbacks immediately after the I/O polling and execution phase, which can be important in some more advanced use cases. Alright, and finally, the 4th phase is for close callbacks, which are, again, not that important for us, but I put this here anyway for the sake of completeness. Basically, in this phase, all close events are processed, for example, for when a web server or a WebSocket shut down. So these are the 4 phases in the event loop, but besides these 4 callback queues that we just saw, there are actually also 2 other queues. The next tick queue and the other microtasks queue, which is mainly for resolved promises. If you're not familiar with promises, we will talk about them a bit in a later section. Anyway, if there are any callbacks in one of these 2 queues to be processed, they will be executed right after the current phase of the event loop finishes, instead of waiting for the entire loop to finish. Okay? So in other words, after each of these 4 phases, if there are any callbacks in these 2 special queues, they will be executed right away. Now, for example, imagine that a promise resolves and returns some data from an API call, while the callback of an expired timer is running. So in this case, the promise callback will be executed right after the one from the timer finishes. Okay? And the same logic also applies to the next tick queue, which we didn't talk about yet. So basically, process.nextTick is a function that we can use when we really need to execute a certain callback right after the current event loop phase. It's a bit similar to setImmediate, with the difference that setImmediate only runs after the IO callback phase. What is similar though is that both are for really advanced use cases, and we're probably not even going to need them throughout this course. But anyway, I wanted to include these more complex stuff here as well, so that you have the tools that you need if you really need to dig deep into Node.js if you want to. Alright, and with that, we actually finished one tick of the event loop. And the tick is basically just one cycle in this loop. So now it's time to decide whether the loop should continue to the next tick or if the program should exit. And how does Node do that? Well, it's very simple. Node simply checks whether there are any timers or I/O tasks that are still running in the background. And if there aren't any, then it will exit the application. But if there are any pending timers or I/O tasks, well, then it will continue running the event loop and go straight to the next tick. So for example, when we're listening for incoming HTTP requests, like we did in our Node farm project in the previous section, we're basically running an I/O task. And that is why the event loop, and therefore Node.js, keep running and keep listening for new HTTP requests coming in, instead of just exiting the application. Also, when we're writing or reading a file in the background, that's also an I/O task. And so it makes sense that the app doesn't exit while it's working with that file, alright? Okay, and this is basically what you should know about the Node.js event loop. If you need even more detail than this, well, you can always try to read the official Node documentation, which should be quite easy for you to understand at this point, now that you already understand most of the event loop anyway. And I just want to emphasize that it's really important for you to correctly understand the event loop, so that you can write your own performant code and also debug your own code when something goes wrong in an unexpected way. And now just to finish, let's review some of the stuff we talked about here. So in a nutshell, the most important thing that I want you to understand from this lecture, and maybe from this entire course, is that the event loop is what makes asynchronous programming possible in Node.js, making it the most important feature in Node's design and making Node.js completely different from other platforms. It takes care of all incoming events and performs orchestration by offloading heavier tasks into the thread pool and doing the more simple work itself. Also, remember that we need the event loop because in Node.js everything works in one single thread, and so you can have thousands or millions of users accessing the same thread at the same time. This makes Node so lightweight and scalable, but at the same time it comes with the danger of blocking our single thread, which would make the entire app slow or even stop for all your users accessing the app, right? Now in other languages, like PHP running on an Apache server, basically a new thread is created for each new user, which is way more resource intensive, but on the other hand, there is no danger of blocking, right? So that whole model makes it a bit easier to use PHP for beginners, but of course, it comes with its own disadvantages, which I'm not going to go into at this point. Anyway, let me again remind you that it's your responsibility to not block the event loop. And so here's a couple of guidelines for that. First off, don't use the sync versions of functions in the fs, crypto, or zlib modules in your callback functions, okay? So in our first project, we actually did use the synchronous version, but it was in the top level code, so outside of any callback. And since that code runs before the event loop even starts, well, it's no problem to use the synchronous version there. Also, and this is probably pretty obvious, don't perform very complex calculations in the event loop. So stuff like crunching millions of numbers in loops inside of loops, or something like that. Next, be careful with JSON in very large objects, because at some point it can start to take a long time to parse or to stringify JSON. And finally, don't use all too complex regular expressions, for example with multiple nested quantifiers or back references, because again, they can take longer than expected. And these are of course just a couple of high-level guidelines, but they will get you started on the right path. Now there are some potential solutions to these blocking problems, like manually offloading to the thread pool or using child processes. And we might talk about this by the end of the course or sometime in the future. But for now, it's important that you understand and follow this advice of really not blocking the event loop. Alright? Next up, I'm going to give you a small example to show you some of the stuff that we talked about in practice. Let's now write some code in order to get a better understanding of what happens in the event loop. So just like before, to get started with the coding part of the section, go ahead and grab the starter files for this section, copy them somewhere, and then open up the project in your code editor. So I have it here on the desktop and in my VS Code, and all we have here to start is this test file.txt. And so I'm going to create a new file here, and I'm going to call it the eventloop.js. Alright, now it is actually extremely difficult to simulate the event loop properly, because we can't really put many callbacks in all the callback queues that we talked about before all at the same time, right? That situation happens when, for example, a lot of requests are coming into your app, but here locally, that's just very hard to replicate. But anyway, we will still do some very interesting experiments using some of the stuff that we learned in the last video. And what we're going to do is to write a bunch of lines of code and then try to figure out in which order they should be executed in the event loop and analyze if the results that we get actually make sense. So let's start by writing a set timeout. So basically, in order to set a timer, and I'm using an arrow function here, and the only thing that I'm going to do is to log to console some string. So console.log timer 1 finished, and I want this to expire right after 0 seconds. Okay, give it a save, and then you see that it actually corrected this string here, so it changed this quotes and added the semicolon, and that's because of the prettier extension that we installed before. Now I'm not going to configure it here, because for this small example, that's not really necessary. Okay, so that is setting a timer. Then let's also use set immediate. So remember that from the last video. Okay, now I'm not going to explain a lot here. For now, let's write this code and then analyze what happens. Okay, so set immediate. And just like the other timer, it receives a callback function. And all we're going to do is to write the immediate one finished. And this one doesn't have any time, because that's not necessary, because as the name says, it is immediate. Then another thing that we want to do is to read this file here and then pass a callback function. Okay, so the first thing is that we have to require the correct module. So fs, and now fs.read file, and we want test file.txt, and then something to happen. And just like before, let's just say here, in this case, IO finished. All right. So IO, because this callback here is actually related to a IO task, which actually gets its own face in the event loop, right? And then finally, let's just add a console.log here saying, well, hello from the top level code. Okay, so top level code, because it's actually the only one that is not inside of any callback. So in this very small example that we have for now, let's try to figure out what should happen first. Well, Remember that the first step when we load a module is that its top-level code gets executed. So right away, we should see this console.log here, right? Only then later, we should see the other logs coming from these other callbacks, because these callbacks will actually run in the event loop. So let's try to see if that's actually the case and then analyze it a bit better even. So opening up the console here, and again, I'm doing that by using terminal, or actually in the view. So this terminal here, all right? So node event loop.js, or actually before we do so, I need to fix this typo here. So it's test file, not text file. Okay, but now we're ready to run this command, and the results are in. So the first log that we have here is hello from the top level code, and that was expected, right? Because this is a code that gets executed immediately. Then after that, we have these 3 outputs, but they are actually in no particular order. And that's because this code here, so this code is actually not in an IO cycle. So it's not running inside of the event loop because it's not running inside of any callback function, okay? So on your computer, you might actually see this log here before this one. And then this one here is only the last one because this kind of big file here takes some time to read. And so it's probably always going to be the last one. So again, at this point, the order of these 3 here doesn't have anything to do with the event loop because they're actually not running inside the event loop just yet. For that, we will have to move them, or at least move these 2 here, inside a callback function. And so for that, we're going to use this one here actually. So let me put it here and say timer 2 and timer 2 here, or immediate 2. And I'm also going to add another timer here. So timer 3, and this one is going to run for 3 seconds. So that is 3000 milliseconds. So let's now try the result of this one. But before we do that, let's actually think why right after all the code before had run, the program then exited and went back to the prompt here. So remember how Node.js decides if it should continue running the event loop? Well, it does so by asking if there is still any timer running in the background. And if so, it will not finish. And if there is still a pending timer, well, then it's not going to exit the program. But if there's not, which was the case in the first example here, then it immediately exits the program. Okay? But now we actually have one timer here. So this one will run for 3 seconds. And so let's try to figure out what happens here. Okay, so you see that it's not exiting, and only now, after timer 3 has finished, it did then exit the application. Okay, so let's actually just see that again. So all these logs, timer's running, timer finished, and so it exited the application. Now about these results here, let's actually make this here a bit easier to see and add just a small separator here. Okay, clean this. Okay. So these 4 ones here are the outputs that were not really running in the event loop, but these 3 here were actually coming out of the event loop. So let's now analyze these results. Now, if you remember the diagram from the previous lecture, you will probably have thought that the timer, so timer 2 here, should actually finish before the setImmediate, because in the diagram it actually appeared first right at the top of the event loop. So we have this set timeout here with 0, which should kind of be the same as setImmediate, right? So why does setImmediate actually appear before the set timeout? Well, there's something that I didn't really explain in the last video because I didn't want to make it even more confusing. And that is that the event loop actually waits for stuff to happen in the poll phase. So in that phase where IO callbacks are handled. So when this queue of callbacks is empty, which is the case in our fictional example here, so we have no IO callbacks, all we have is these timers, well, then the event loop will wait in this phase until there is an expired timer. But if we scheduled a callback using setImmediate, then that callback will actually be executed right away after the polling phase and even before expired timers, if there is one. And in this case, the timer expires right away, so after 0 seconds, but again, the event loop actually waits, so it pauses in the polling phase. And so that set immediate callback is actually executed first. So that is the whole reason why we have this immediate here after we have the timers. Okay? And I know this sounds very confusing, and I completely agree, but really that's just the way Node.js works. And now let's make this even a little bit more confusing and add the process.nextTick that we talked about also in the last lecture. So we say process.nextTick, and then just like before, we simply pass it a callback function. And again, I just want to log to the console, and I'm going to say process.nextTick. So what do you think will happen in this case? Go ahead and make a guess, and once you're ready, you can then run this. So let's do that. Save it here first, run it, and so here we go. So the results are again in, and now the first callback that was executed was actually this function here. So that's why we have process.nextTick right in the first one. So why was this callback function of process.nextTick the first one of all of them to be executed? Well, remember that nextTick is part of the microtasks queue, which get executed after each phase, so not just after one entire tick. And so what happened here is that this callback function actually ran before the phase where this callback function here ran and the phase before that. Okay? Now, nextTick is actually really a misleading name because a tick is actually an entire loop, but nextTick actually happens before the next loop phase and not the entire tick. So that's what I was saying before. Then on the other side, set immediate would make you think that its callback would be like executed immediately, but it actually doesn't, right? So set immediate actually gets executed once per tick, while nextTick gets executed immediately. And so their two names should actually be switched. They should be the other way around. And this can cause a lot of confusion, so it's best to just always stick to one of them. And that's usually set immediate and not process.nextTick. Now anyway, as I mentioned in the last video, these mechanisms are actually more for pretty advanced use cases, which is why we will probably not use them in our project. But if you want to learn more about them, you can always read the official Node documentation. Okay? So with this, we have simulated some aspects of the event loop, but to finish, I want to just quickly introduce something about the thread pool as well. And for that, we're going to do a more complex operation that will actually be offloaded to the thread pool and take a look at how long these operations take to run and how we can change the thread pool size that we talked about before. So we're going to use some cryptography here to basically encrypt a password. So that's a new package we hadn't used before, and it's called crypto. But I mentioned earlier that actually all the functions from this package, they will be offloaded automatically by the event loop to the thread pool. And so that's what we're going to test out now. And let's use this now. So crypto.pb, so we're going to use an encryption function called pbkdf2. So kind of a weird name. And now we pass in the secret string, which let's just say password. Then we need a string to salt the password. And the implementations here don't really matter. So for now, I'm not going to go into any detail of how this works. We're going to do that later. Okay, so here we just need the key length. So this number here is just for the number of iterations. Then this is the key length. And then finally the algorithm, which is going to be used to encrypt the password. So these numbers will simply increase the time it takes for the encryption. Okay, and then finally, it also takes a callback function. And all I'm going to do here is to do another console.log and just say password encrypted. Now, for the purpose of this demonstration, I actually want to show you how much time each of these operations take. So what we're going to do is to basically define a variable in the beginning, set it to date.now. So that is the current date in milliseconds. And then here, all we have to do is to log not only the string, but also date.now, which will be the date at this point in milliseconds minus the start. And so that will then give us the amount of milliseconds that have passed in order to do this calculation. Okay, so let's try it out, give it a save, and run it again. And so here you see that it took 1855 milliseconds, so almost 2 seconds to encrypt this password. Okay, but now let's actually duplicate this code, or actually I want 4 instances of this to show you something. So if we run this now, it should probably take approximately the same amount of time. And yeah, it does. So it was 1.8 seconds, now it's 2.2 seconds, which is quite similar. Okay? And remember that I told you in one of the earlier lectures that by default the size of the thread pool is 4. So there are 4 threads doing the work at the same time. And so that's why these 4 password encryptions take approximately the same time and happen basically all at the same time. But we can actually change that thread pool size. So let me show you how we do that. And we do that by saying process.env, and that's an environmental variable. And again, we're going to talk more about that later. And uv, which stands for libuv, thread pool size. So if we set this to 1, we will only have 1 thread in our thread pool. So let's try that again. And so let's see what happens now. So you see that they all take much longer to calculate. Basically, they are calculated one after the other. So this one the first, then this one here takes double the time. And again, that's because this one can only start as soon as the first one is completed. And the same with the third and the fourth one. Now let's say we change it to 2. Then we should see the first 2 ones with the same time, and exactly the second 2 also with a similar time. So that makes sense, right? Just for the sake of completion here, now the same thing with 3. So these 3 have a similar time, and then the last one. All right, so this is how the thread pool works basically. So I decided to not only focus on the event loop, but also to give you an overview, a very quick one, of the thread pool and how we can change the thread pool size. Okay, keep in mind that this code here is actually still asynchronous because we pass in a callback function. Okay, and we could actually use the synchronous version, but that would then block the event loop. Want to see that? So let me very quickly show that to you as well. So that one was not really planned, but let's do it anyway, because it's very interesting to see that, I think. Okay, so that would work like this. We use, again, the sync version of the same function, which in Node is many times available. Remember, we have the same for the read file. So we have read file, which accepts a callback, and we have read file sync, which is the synchronous version, which doesn't accept any callback. So just like this. So this one will then encrypt the password, block the code execution, and then move on to the next line, which will then log this here to the console. So let's now duplicate this here. Oh, that was too much. Get rid of this one here. And so now these 4 password encryptions will no longer run in the event loop. And so they will no longer be offloaded to the thread pool. Okay? And so now, even if we have the thread pool size of 4, let's see what happens. So you see, they happen completely in a synchronous way. So one after the other. And what is even worse is that all of these timers here, even next tick and the immediate one, only appeared after the password encryptions happened. So this really was blocking the entire execution. Even if this timer here, for example this one here, was finished after 0 seconds, and this one after 3 seconds, but they all had to wait 7 seconds until all of these password encryptions here were finally ready. Again, because they were not running inside the event loop, but these were. And so they were basically working in the background and could only be picked up by the events loop when they were ready, right after these 4 password encryptions. So this one was another great example of seeing the code blocking and event loop all in action. Okay, so that was enough for one lecture. I hope that you found it interesting, and I'll see you right in the next one. In this video and the next one, we're going to dive into yet another important piece of the Node.js architecture, which is events and the event-driven architecture. So most of Node's core modules, like the ones we already used, like HTTP, file system, and timers, are built around an event-driven architecture. And we can of course also use this architecture to our advantage in our own code. And the concept is actually quite simple. So in Node, there are certain objects called event emitters that emit named events as soon as something important happens in the app, like a request hitting a server, or a timer expiring, or a file finishing to read. These events can then be picked up by event listeners that we developers set up, which will fire off callback functions that are attached to each listener. Okay? So again, on one hand we have event emitters, and on the other hand, event listeners that will react to emitted events by calling callback functions. Simple, right? And probably the best way to understand this is to look at an example. And so let's briefly understand how Node uses the event-driven architecture to handle server requests in the HTTP module that we already used in another section. So when we want to create a server, we use the createServer method and save it to a server variable. This implementation here is a bit different from what we did before, but it works the exact same way. Anyway, this serverOn method is how we actually create a listener, and in this case, for the request event. So let's say we have our server running and a new request is made. The server acts as an emitter and will automatically emit an event called request each time that a request hits the server. Simple, right? Then, since we already have a listener set up for this exact event, the callback function that we attached to this listener will automatically be called. And this kind of function we already know from before. It will simply send some data back to the client. Now, it works this way because, behind the scenes, the server is actually an instance of the Node.js event emitter class. So it inherits all this event emitting and listening logic from that event emitter class. And don't worry, we're going to use it all right in the next video so that you become familiar with all this logic. Now, just to finish this lecture, I believe it's important to mention that this event emitter logic is called the observer pattern in JavaScript programming in general, and it's quite a popular pattern with many use cases. So the idea is that there is an observer, in this case the event listener, which keeps waiting, keeps observing the subject that will eventually emit the event that the listener is waiting for. And the opposite of this pattern is simply functions calling other function, which is something that we're more used to actually, right? But the observer pattern has been designed to react rather than to call. And that is because there is a huge benefit of using this architecture, which is the fact that everything is more decoupled. We don't have, for example, functions from the file system module calling functions from the HTTP module, because that would be a huge mess. Instead, these modules are nicely decoupled and self-contained, each emitting events that other functions, even if they come from other modules, can respond to. Also, using an event-driven architecture makes it way more straightforward to react multiple times to the same event. All we have to do is to set up multiple listeners, right? Okay, and that is Node's event-driven architecture in a nutshell. And don't worry if this seems a bit too theoretical, you will see this logic being used in many situations throughout the course, starting right in the next video. As promised, we will now use event emitters and listeners in practice. And we start by creating a new file here. So events.js, and close up this one. So to use the built-in Node events, we need to require the events module. And from that, we're going to require an event emitter class. So event emitter, this is kind of the standard name for the result of requiring this events module. So again, this is a built-in Node module, okay? And now to create a new emitter, we simply create an instance basically of the class that we just imported. So very simple. My emitter is a new event emitter. So event emitter, just like this. So remember from the last video that event emitters can emit named events, and we can then subscribe to these events. So basically listen to them and then react accordingly. Okay, so it's a bit like setting up an event listener on a DOM element, for example, for clicking on a button. And I'm sure you've done that before when working with JavaScript on the client side, right? So our emitter will eventually emit a named event. Okay, so let's set that up. And let's simply pretend that we're building like an online store or something. Okay, so we can say my emitter.emit, and then we can make up any event name that we want. Okay, so we want to emit an event called new sale. Okay, and using the example of clicking on a button that I used before, this emitting here is like as if we were clicking on the button. And so now we have to set up these listeners. Okay, and let me actually do that before here. And so again, we use our my emitter object, and on that we use the on method. Okay, so on new sale, and then the callback function, which is gonna get executed as soon as the event is emitted. So as usually, let's simply log something to the console. There was a new sale. Okay, and let's add another one. So remember that I said earlier that one of the nice things about these event emitters is that we can actually set up multiple listeners for the same event. So let's do that here. And so again, of course, we're listening for the new sale event. We then log just something else. Doesn't really matter here. So customer name, for example, Jonas. So let's test this out. Clear the one from before, and we use Node and then events.js. So there was a sale and customer name Jonas. And so you see already that it's working. So great. So this is the observer pattern. Remember, where this one here is the object that emits the events, and then these two here, so this on and this on, these are the observers. They observe the emitter and wait until it emits the new sale event. And of course, our emitter could also emit other events, like new customer or new order or something like that, and we could then add listeners for that one as well. Okay? Now another thing that I wanted to show you is that we can even pass arguments to the event listener by passing them as an additional argument in the emitter. Here. So let's say that we pass 9, so in this case just a number, and we then have a listener that wants to use that. So my emitter, new sale, and so now this callback function can take an argument. And so let's call it stock. So basically the amount of items that are left from the product that we're selling here. So let's use a template string. There are now stock items left in stock. So if we run this now, we should see there are now 9 items left in stock because we emitted this event basically with a 9, and the listener can then pick up this value here as an argument of their callback functions. So this stock variable here in this case. So if you run this again, then here there are 9 items left in stock. So perfect. And you see that these 3 logs here appear in the exact same order that they are declared in the code. Okay, and so that's the normal behavior. If we have multiple listeners for the same event, then they will run synchronously, so one after the other, in the order that they were in the code. So this small example works perfectly already, but if we were to use this pattern in real life, then it's a best practice to create a new class that will actually inherit from the Node event emitter. So something like this. So let's say class sales extends event emitter. And that is ES6 or ES 2015 syntax for class inheritance. And again, I hope that you're familiar with ES6 at the time you're taking this course, okay? So in broad terms, the event emitter is a class, so the one that we imported from events, and our sales class is the new class that we're creating and that inherits everything from the event emitter class, okay? Then in ES6, each class gets a constructor, which is a function that is run as soon as we create a new object from a class, okay? And what we need to do here is to call super, and that's something that we always have to do when we extend another superclass, okay? So this is the parent class, and this is the superclass. And by running super, we then get access to all the methods of the parent class. So again, event emitter in this case, okay? And so now what we have to do is to actually move this one down. And so now my emitter is a new sales. Okay, and so now it will work exactly the same. And indeed, here we go. And actually, this mechanism that I just showed you here, so basically extending the event emitter class, is exactly how the different Node modules like HTTP, file system, and many other Node core modules implement events internally. Okay, so all of them actually inherit from the event emitter class. Okay, and with this small example working, let's actually now try another thing. So since I was just talking about the HTTP module, let me actually demonstrate to you that it is completely based on events. Okay, so we have this part working. Let's create a couple of comments here, something, and then create another example down here. All right, and what we're going to do is to basically create a small web server and then actually listen to the event that it emits. Okay, so up here, we need to import the HTTP module. And then down here, we can use it. So we're creating a server, and now I'm going to do it a little bit different than the way we did it in the first intro section, okay? But it actually works the exact same way. So all I'm going to do here is now http.create server, and just like this. And now what I'm going to do is to basically listen to different events that the server will emit. So for that, again, I'm using on. And so if you see .on anywhere in a Node project, well, then you already know that you are listening or that the code is listening to a foreign event, okay? And so the one that we are listening here is the request event, okay? And so now it works just the same as before. We have a callback function which gets access to the request and the response. So nothing new at this point. We did exactly that in the Node farm project. Okay, so console.log request received, and then let's also send something back. Just the same text actually, okay? And of course, we can listen multiple times to the same event. So let's just say here another request using some emoji here just to make it pop a little bit more. And no, it's not appearing. What's going on here? Now, here we go. So listening to request, and we can also listen to the close event. So server on close, and that is the event that is fired when the server, as you can imagine, closes down. Okay, so that is listening to the events. And now remember, we also have to actually start the server. So, and we start the server up by using server.listen. Pass in the port, the address, which is localhost again for us in this case, at point 1, and then or callback function, which is optional, but let's include it here again. Waiting for requests. So let's actually start this. And we see waiting for requests. And the application is not shutting down. And now you know why it doesn't shut down, right? It is so because the event loop is still waiting for incoming I/O, right? So that's what we learned in the event loop lectures. Okay, now let's actually do a request on port 8000 on this URL. And here we go. So we see request received. So this works because as soon as there is a new request, the server automatically emits the request object. Okay, and we can see that here, of course. And here in the console, we see our request received string. And I actually wanted to get another one here. So yeah, we can of course only send one response. And so here I should have another console.log instead. So let's exit this, start it up again, reload. And yeah, so now we get a request received, which is from this first event listener, and another request from this second event listener. One thing that you're probably noticing is that each of these here actually is logged twice. So that means that the server is actually emitting the request event twice as well. So let's see why that is. So console.log request.url. So with that, we can then get access to the URL of the request. Let's quit it here, run it again, reload. And so we have one for the root URL and then one for the favicon.ico. So browsers automatically try to request a favicon for each website. Okay, so that is why each of these appeared twice actually. Okay, so you see that not always we have to actually also emit events. That is more when we try to use the event emitter on our own. So basically when we're trying to use our custom events in our applications. In this case, of course, we have to emit the events ourselves. But if we're using a built-in Node module, then these functions in there will many times emit their own events, and all we have to do is to listen to them. So that's exactly what we did here. And with that, I think you now know all you need to know about events and are ready to come with me to the next video. Streams are yet another fundamental concept in Node.js. So let's now learn all about them. So first of all, what are streams? Well, with streams, we can process, meaning read and write, data piece by piece without completing the whole read or write operation. Therefore, we don't have to keep all the data in memory to do these operations. For example, when we read a file using streams, we read part of the data, do something with it, then free our memory, and repeat this until the entire file has been processed. Or think of YouTube or Netflix, which are both called streaming companies because they stream video using the same principle. So instead of waiting until the entire video file loads, the processing is done piece by piece, or in chunks, so that you can start watching even before the entire file has been downloaded. So the principle here is not just about Node.js, but universal to computer science in general. So as you can see, this makes streams the perfect candidate for handling large volumes of data, like for example video, or also data that we're receiving piece by piece from an external source. Also, streaming makes the data processing more efficient in terms of memory, because there is no need to keep all the data in memory, and also in terms of time, because we can start processing the data as it arrives rather than waiting until everything arrives. Okay, so now that we know what streams are, let's talk a little bit about how they are implemented in Node.js. So in Node, there are 4 fundamental types of streams: readable streams, writable streams, duplex streams, and transform streams. But the readable and writable ones are the most important ones, and so we're going to focus more on these two. So readable streams are the ones from which we can read. We can consume data. Makes sense, right? Now, streams are everywhere in the core Node modules, so a bit like events, like we talked about before. For example, the data that comes in when an HTTP server gets a request is actually a readable stream. So all the data that is sent with the request comes in piece by piece and not in one large piece. Also, another example from the file system is that we can read a file piece by piece by using a read stream from the FS module, which can actually be quite useful for large text files. Alright, now another important thing to know is that streams are actually instances of the event emitter class, meaning that all streams can emit and listen to named events, just like we learned in the last lecture. In the case of readable streams, they can emit and we can listen to many different events, but the most important two are the data and the end events. The data event is emitted when there is a new piece of data to consume, and the end event is emitted as soon as there is no more data to consume. And of course, we can then react to these events accordingly. And actually, we're going to do exactly that in the next video, so to practice how to work with streams. Finally, besides events, we also have important functions that we can use on streams. And in the case of readable streams, the most important ones are the pipe and the read functions. And again, you will see these in action in the next video, especially the super important pipe function, which basically allows us to plug streams together, passing data from one stream to another without having to worry much about events at all. Okay, next up, writable streams are the ones to which we can write data. So basically the opposite of readable streams. A great example is the HTTP response that we can send back to the client and which is actually a writable stream. So a stream that we can write data into. So when we want to send data, we have to write it somewhere, right? And that somewhere is a writable stream. And that makes perfect sense, right? For example, if we wanted to send a big video file to the client, we would stream that result just like Netflix or YouTube do. Now about events, the most important ones are the drain and the finish events. And the most important functions are the write and end functions, some of which you will see in action in the next lecture. Now quickly about duplex streams, they are simply streams that are both readable and writable at the same time. These are a bit less common, but anyway, a good example would be a WebSocket from the Net module. And a WebSocket is basically just a communication channel between client and server that works in both directions and stays open once the connection has been established. Finally, transform streams are duplex streams, so streams that are both readable and writable, which at the same time can modify or transform the data as it is read or written. A good example of this one is the zlib core module to compress data, which actually uses a transform stream. Alright, and that's the 4 types of streams and a broad overview of how we can use them. Now there is something important to mention here before we move on, which is the fact that these events and functions that I showed you are for consuming streams that are already implemented, like the ones that I showed you here as our examples. So for example, Node implemented these HTTP requests and responses as streams, and we can then we can use them, using the events and functions that are available for each type of stream. We could of course also implement our own streams and then consume them using these same events and functions. That, however, would be a video for another time, because in order to build most apps, it's most important to know how to actually consume streams, not really how to implement them. Alright? So let's now move on and actually use streams in practice. Alright, let's now actually work with streams. And again, starting by creating a new file. Alright, now let's say that for some reason in our application, we need to read a large text file from the file system and then send it to the client. So how would we do that? Well, there are multiple ways, and we're going to explore a few of them, starting with the most basic one and moving all the way to the best way of doing this. Okay, so the first thing is to require the file system package, just like before, and also the HTTP module. Let me now show you a nice trick. So let's actually create a server like this. So require the HTTP package, and then from here we can right away call create server. So just like this. Okay, so the result of requiring HTTP is the HTTP object, and on there we can then use create server, just like this, and then save it into a variable. So that is yet another way of creating a new server with writing even a bit less code. Okay, and so just like before, let's now listen to the request event and specify our callback here. So the first solution that we're going to use is the easiest and most straightforward one, which is to simply read the file into a variable, and then once that's done, send it to the client in a way that we already know how to do it. So that one's very simple. And let me write a comment here for that. So solution 1, and so fs.read file, then our test file again. And then once that's ready, we call our callback function in which we have access to the data. But first let's handle the error. So for example, in case that the file does not exist, and in that case we simply log the error to the console. But otherwise, we simply send this data back to the client. So we use the response object just like we did before many times, and then .end and the data. So give it a save. And so that is the first and the simplest solution, right? But before we can test this, we need to actually also start a server, right? So we use listen to do that. And the port, the same one as before. Then localhost and our callback function. Okay, so let's see if this actually works. And of course not, because I actually didn't even start the application. So now it says listening, and now let's see what happens here. And here we go. So this file is huge. It has Node.js is the best written in it, like 10,000 times or something. And so it takes a lot of time until it loads entirely. And we're not really interested in loading everything. So let's stop this here and go back to our code. So this works just fine, the solution 1 that we have here in this case. But the problem is that with this solution, Node will actually have to load the entire file into memory, because only after that's ready, it can then send that data. Now this is a problem when the file is big, and also when there are a ton of requests hitting your server, because the Node process will very quickly run out of resources, and your app will quit working, everything will crash, and your users will not be happy, believe me. So this solution here does work when we're just creating something small locally for just ourselves, for example, but in a production-ready application, you cannot use a piece of code like this. Okay, so let's move on to our second solution. And in that solution, we will actually use streams. Okay, so let's comment out this part and move on to solution number 2. And the idea here is that we actually don't really need to read this data from the file into a variable, right? We don't need this variable. So instead of reading the data into a variable and having to store that variable into memory, we will just create a readable stream. Then as we receive each chunk of data, we send it to the client as a response, which is a writable stream, remember. So let me now show you how we can use streams. So we create a variable. Let's call it readable here. And then from the file system again, we use create read stream. Just like this. Then this, of course, small. And now the name of the file that we're trying to read. So that is again testfile.txt. Okay, perfect. So this now creates a stream from the data that is in this text file, which we can then consume piece by piece, so chunk by chunk. And how do we do that? Well, remember from the last lecture that each time there is a new piece of data that we can consume, a readable stream emits the data event. Okay? And so we can listen to that just like we learned in the events lecture. So readable.on data, and then our callback function. And in that callback function, we have access to that piece of data, so to that chunk. So let me call it chunk here in our callback function. And so now we can handle this piece of data. And what we're going to do with this piece of data, with this chunk, is to actually write it to a writable stream, which is the response. So response.write this chunk. Okay? So again, remember that the response is a writable stream. So just as I mentioned in the previous video, right? And so we can now use the write method to send every single piece of data into that stream. Okay? And so with this, effectively, we're streaming the content from the file right to the client. Okay? You understand the difference? So before, we read everything at once into a variable, and once that was ready, we then send that entire piece of data back to the client. But in this situation with the stream, it is different. We're effectively streaming the file. So we read one piece of the file, and as soon as that's available, we send it right to the client using the write method of the response stream. Then when the next piece is available, then that piece will be sent, and all the way until the entire file is read and streamed to the client. Okay? Now, just to finish, we also have to handle the event when all the data is read. So when the stream is basically finished reading the data from the file. So in that case, the end event will be emitted. And so as soon as that happens, what we're going to do is to do res.end. Okay? And we used this one before. So calling end on the response. We did that before, right? And now it makes actually more sense. Because again, the response is also a stream. And the end method signals that no more data will be written to this writable stream. Okay? So up here, all we did was actually use response.end with the data in it. So we did no streaming. All we did was in the end to send some data. Now in this case, we're not passing anything into this end method because we already sent all the data using res.write chunk by chunk. And so when the readable stream is finished reading its file, well, all we have to do is to then signal that we're ready using res.end like this. Okay, so we always need to use this data and this end event here one after another like this. Because otherwise, the response will actually never really be sent to the client. Okay, so without this piece here, this entire solution would not really work. Okay, so let's now close this one, start again, and read again. And so you see that it's actually working again. Okay, now this time without the problems that we had with the first solution. Let's stop this here and go back to our code, because I want to show you now that there is another event that we can listen to on a readable stream, which is the error event. So readable.error, and in this callback function, we have access to the error object. Okay, so in this case, we will log this error to console, and then send the result of file not found. And we can also set the status code to an error, so 500, for example. So usually it's automatically set to 200, which means okay. But in this case, we have a server error, which means that we want to send back the code 500. All right. So let's now, or actually I need to quit this again. So let's see what happens now. Oh, we already have an error right here. Rest.status is not a function. And yeah, actually it's status code. So this is the way that you write it in Express. So I'm already used to writing Express so much. So Express is a Node.js framework, which we're going to use in the rest of the course. And in Express, you do it like this. And so that was the problem. So I'm already a bit too used to writing Express. So let's go back. And yeah, so now we see file not found. And if we open up the DevTools, you see our 500 error code that we just sent before. And if we go to our network tab, let's try that again. You have the status code here as well. So just like we saw in one of the previous videos, in another section actually. So this is how we can inspect this kind of stuff in the network tab. All right. So let's fix it here, give it a save. And okay. So this again works just perfectly, but there still is a problem with this approach that I just showed you. And the problem is that our readable stream, so the one that we're using to read the file from the disk, is much, much faster than actually sending the result with the response writable stream over the network. And this will overwhelm the response stream, which cannot handle all this incoming data so fast. And this problem is called back pressure. And it's a real problem that can happen in real situations. So in this case, back pressure happens when the response cannot send the data nearly as fast as it is receiving it from the file. Does that make sense? So we have to fix that solution and come up with an even better one. And so we will create solution 3. And that is actually the final one. Okay, so no more solutions than 3. So the secret here is to actually use that pipe operator that I mentioned in the last video. Okay, so the pipe operator is available on all readable streams, and it allows us to pipe the output of a readable stream right into the input of a writable stream. Okay, and that will then fix the problem of back pressure, because it will automatically handle the speed, basically, of the data coming in and the speed of the data going out. Okay, so let's actually get our readable stream here. Okay, so that is our readable stream. And now all we have to do is to take our readable stream, use the pipe method on it, and then put in a writable stream. And that is the response. And that's actually it. That's all we have to do for this solution. Okay, so it always works like this. Let me write it out here as a comment. So we need a readable source, basically. Okay, so again, this is just to explain it to you. Then we can use the pipe on it, and here we will have to put a writable destination. So this is where our data comes from, and it has to be a readable stream, and that data we can then pipe into a writable destination. So in this case, our destination is the response, okay? Now this stream here can actually be a duplex or a transform stream as well, but what matters is that we can write to the stream. And response, of course, is such a stream. So we can, of course, write to the response that will be sent to the client, okay? So the pipe operator automatically solves the problem of back pressure that we had previously. And it's also actually a much more elegant and straightforward solution. So what we did here before was just to show you all the ways in which we can use the stream methods and events in order to create this kind of solution. And of course, they have many use cases, but in a problem like this, the pipe operator is actually the best solution. Behind the scenes, it does something like this here actually, but again in a much more straightforward way for us to write, because it handles all this stuff internally behind the scenes. So I believe that pipe here is actually the easiest way of consuming and writing streams, unless, of course, as I mentioned, we need a more customized solutions. And then we have to use these more complicated tools like these events and methods that I showed you before. All right, so just to finish, let's quit the process here, start it again, and of course see if it still works, which it does. And so our work is done here. So we're finished with this lecture and ready to go straight to the next one. As the last part in this section, let's talk about how Node.js modules actually work behind the scenes. So first of all, in a Node.js module system, each JavaScript file is treated as a separate module. And we already played around a bit with modules in the intro section, especially by using the require function and exporting data from modules. And so that's the fundamentals of common JS modules, which is the module system that Node uses, because it works especially well on the server. Now, there's also the native ECMAScript or ES module system that you might already be familiar with, especially if you took my complete JavaScript course or if you have been writing JavaScript on the front end lately. And this ES module system that I was talking about was developed to work in the browser using the import-export syntax. So I just wanted to make it clear that these are two different module systems that you will see in different situations, so don't be confused. There have also been attempts to implement native ES modules in Node.js, especially using file extensions like .mjs, but so far it's not really become a popular thing to use. And so unless you're watching this course in the far future, you will probably always be using the common JS system with Node. Now, you might be wondering why in Node.js each and every module actually gets access to the require function in order to import modules in the first place, right? I mean, it's not a standard JavaScript function, so where does it come from? And how exactly does it work behind the scenes? Well, let's find out. So the question here is, what happens each time that we require a module by calling the require function with the module name as the argument? So as a very broad overview, the following steps are executed behind the scenes. First, the path to the required module is resolved and the file is loaded. Then a process called wrapping happens. After that, the module code is executed and the module exports are returned. And finally, the entire module gets cached. Alright, so let's now look at each step in more detail. So first off, how does Node know which file to load when we require a module? Because remember, we can actually load 3 different kinds of modules. Node's core modules, our own modules, or third-party modules from NPM, like Express, which is the Node framework that we're going to use throughout most of the course. So this process is known as resolving the file path. And here is how it works. When the require function receives the module name as its input, it will first try to load a core module with that name, like for example the HTTP module. It will automatically find the path to that module and then load it. Now, if the path starts with a dot or 2 dot, it means that it's a developer module, because we indicate the relative path to our file. So Node will try to load that file, but if there is no file with that name, well, then it will look for a folder instead and load index.js if it's in that folder. So in this example, it will try to load lib/controller.js. Remember that we can drop the .js when requiring a module. In case there is no file at this path, it will then instead try to open index.js from the lib/controller folder instead. Make sense? And finally, if the required module is neither a core module nor a developer module, Node will assume it's a module from NPM. And remember, on a module that we load from NPM, we actually don't need to write the path when we require it. Just the module name, just the way it works on a core module. So these third-party modules are stored in the Node modules folder, and so Node will step into that folder and try to find the module there, and then load it. And of course, if the file can't be found anywhere, then an error is thrown and the execution of the app is stopped. Alright, moving on, after the module is loaded, the module's code is wrapped into a special function, which will give us access to a couple of special objects. And so this step is where the magic happens. It is here where we get the answer to the question, where does the require function actually come from, and why do we have access to it? Well, it's because the Node.js runtime takes the code of our module and puts it inside the immediately invoked function expression, or IFI, that you can see here. So Node does actually not directly execute the code that we write into a file, but instead the wrapper function that will contain our code in its body. It also passes the exports, require, module, file name, and dir name objects into it. And so that is why in every module we automatically have access to stuff like the require function. So these are basically like global variables that are injected into each and every module. Okay? Now, by doing this, Node achieves two very important things. First, of course, is giving developers access to all these variables we just talked about, which is very helpful. And second, it keeps the top-level variables that we define in our modules private, so scoped only to the current module, instead of leaking everything into the global object. So imagine for a second that we declared a variable x in one of our modules, and then included an npm module that also used a variable called x. Without this mechanism, our own variable would then get overwritten, and the entire app would just not work. So each module having its private scope is absolutely crucial, and is achieved through this clever trick of wrapping our code into this special function. Alright, so let's now take a quick look at each object that our module gets. First, the require function, which we already know about. Then there is a module object, which is just a reference to the current module, and which for us is most important when it comes to exporting data. The same applies to the exports object, which we're going to discuss in a moment. Finally, there are the convenience variables file name and dir name, which simply contain the absolute path to the current module's file, as well as the current directory name. And that is how the wrapping step of loading a module works. Next up, the code in the module, or to be more precise, in the module's wrapper function, actually gets executed by the Node.js runtime. So nothing fancy here. Alright, so up until this point, the require function has been called with a module name as the argument, the path to the module's file has been resolved and the file loaded, all the code has been wrapped into the wrapper function, which has then been executed. And so now it's time for the require function to actually return something. And what it returns is the exports of the required module. These exports are stored in the module.exports object. Alright? It might look a little bit like this. So again, in each module we can export variables, which will in the end be returned by the require function. And we do that by assigning variables to module.exports or simply to exports, which is just a pointer to module.exports. We will do this in practice in the next video because I know this sounds kind of confusing when I just say it like this. Anyway, here is what you need to know about when to use module.exports or just exports. So if all you want to do is to export one single variable, like one class or one function, you usually use module.exports and set it equal to the variable that you want to export, just like in this example. On the other hand, if you're looking to export multiple named variables, like multiple functions for example, then you should create these as properties of the export object. For example, if we were doing a calculator module, you could create exports.add, exports.multiply, exports.divide, and so on and so forth. Make sense? Again, we're going to do this in the next video, and it will make more sense to you by then. Okay, and this is effectively how we export and import data from one module into the other. Of course, this is also why we usually assign the result of a require function call to a new variable, so that we can save the returned exports. And now just to finish this video real quick, the last step is that modules are actually cached after the first time they are loaded. What this means is that if you require the same module multiple times, you will always get the same result. And the code in the modules is actually only executed in the first call. In subsequent calls, the result is then simply retrieved from cache. Perfect. So I hope that all the logic behind how to work with modules doesn't really look like magic anymore. It's really important to know how all of this works in order to become a great, and above all, a more independent Node.js developer. In this lecture, I want to show you a couple of different things involving modules. And I want to start by basically proving to you that Node does in fact wrap the code in our modules into a wrapper function like I showed you in the last lecture. So let's create a new file again, modules.js, and that's modules like this. Okay, and what I'm going to do here is to log to the console the arguments. Okay, so arguments is an array in JavaScript, and this array contains all the values that were passed into a function. So when I log this arguments array to the console, if we actually see some values there, well, then it means that we're really in a function. Okay, so let's run modules, and indeed, here we have the code in our arguments. And so let's remember the 5 arguments of the wrapper function. The first one is the export, so this one, which is currently empty because we're not exporting anything. The second one is the require function, so we can see that here, we have the require function indeed. Then the third one is called module. Okay, and in module, we have then module export, which again we talked about in the last lecture. And what we have here is not that important. Again, I just want to show you that we're actually in a function right now, so that all this code that we have in this module is indeed wrapped into this wrapper function. Okay, then number 3 and number 4 are the file name and the directory name. And indeed, this is the name of the module that we're currently in, so modules.js. And then here we have the directory name. So I'm on my desktop, and then in this How Node Works folder. So similar to this one here, but then this one has / the module name. Okay, so that proves us that indeed all the code inside a module is wrapped, and that we have access to all these variables, so these arguments. Okay, so I just find this an interesting experiment that we can do. And we can actually do another cool thing. So to actually show you the wrapper function, we can require the module, okay? So there's a module called module, which we actually never use, but internally Node uses it. And in there we have the wrapper. And so that is actually, this property is actually the wrapper function. So we can now take a look at that. And where is that? Ah, yeah, so here it is actually. So this is the wrapper function. And so indeed you see export, require, module, file name, and directory name, and then the function body. And so this is what Node internally use. So basically this template here, it uses it and then fills up the body of this function with our code. Okay, so again, just an interesting experiment here. Now the most important thing that I want to show you here is how we can export and import data from one module into the other. And so let's start by creating a new module here in which I'm going to create a calculator, a bit like I mentioned in the last video. So let's just call this test module 1 because we're going to have a couple of them. And here I'm going to create a calculator class. So again, this is the ES6 syntax of writing classes in JavaScript. So let's add a couple of methods here. So add A and B. We'll of course return A plus B. So very simple stuff. Multiply AB will return A times B. And then let's just do divide as well, just for the sake of completeness here. by b, like this. Give it a save. It nicely formats it. And now we can do module.exports, just like we learned in the last video. And we're exporting our calculator, okay? So again, we use module.exports when we want to export one single value. And in this case, our single value here is the calculator class. So module.exports is exactly what is returned from one module. So whatever we put there, well, then gets exported automatically, right? We can then save the exported value to a variable when importing it. So let's do that now. And now here, we can actually give it any name that we want. So the name that we are exporting on the other side, so in the other module, doesn't matter. We can call it anything we want here. So in that sense, it's just like a normal function return, right? So we can always return any variable, but then call it something else when we basically save the result of a function to a variable, right? So since it's our own module, we have to use the dot slash, so what I did just here, and then test module 1. And the JS, remember, we can just drop that. It's not necessary, okay? And so this C variable here, which is uppercase, because for a class, we usually always use uppercase names. And remember, we are actually exporting a class here, okay? So we can now use that class to do some calculations. So first of all, let's create a new calculator, calculator 1, because later on we're going to have another one, okay? And so now we create a new instance of our calculator like this, and this should be nothing new for you at this point. And then let's log to the console the result of actually using this. So calc1.add, and let's say 2 and 5. Give it a save. And actually let's comment out these two. Save it again, and then node modules. And here we have the result 7. So that's 2 plus 5. So it works, right? And here in our test module, we could actually do it in a more elegant way. So we could assign this class here directly to module.exports, right? So right now we have a class declaration. So that's a little bit like a function declaration where we say like function calculator and then this. And here we say class, okay? But we can do it with a class expression as well. And so like this, we simply don't use the calculator name anyway. Let's copy it, comment it out. Okay, so just like this. So we just say that this is a class and then assign it to a variable. And so that's now an expression. So let's run this again. And we see, of course, our 7 again. Okay, so again, this is just to actually immediately assign the value that we want to module.exports. And that's going to save us then some lines of code and I believe make our code look a bit better. Okay, so that's how we export stuff with module.exports. And now let's see how and when we can use the export shorthand that I also mentioned in the previous video. So let's just create a simple comment here, module.exports, and then here just exports. So a new module test module, and again, module2.js. And so the alternative for doing module.exports is to add properties to the exports object itself. So we can do it like this. And using again the calculator example from before, we could do it like this. So we can simply add properties to the exports object. So A and B will return A plus B. Exports dot multiply AB will return A times B. And now let's just duplicate just for the sake of completeness again. And okay. So we created basically 3 anonymous functions here, D3, and assigned them to 3 properties of exports. And so now when we import this module on the other side, so in modules.js, we will get basically access to this export object. So let me show that to you. So let's say const calc2 is require. Again, don't forget the dot and slash because it is our own module. Okay, and so now this calc2 here is the exports object. Okay, so let me show that to you. Console.log calc2.add 2 and 5. So that should give us the exact same result as before. And indeed, here is our 7 just like before. And if we add, and if we did multiply, well, then that should be, of course, 10. And so yeah, we have 7 from the addition here, and then this multiply gives us 10. So I hope that this really makes a difference between module.exports and exports clear. So again, when we're using simply exports, we can add stuff to this object, so basically properties, and then when we import that, so when we require this module, the result that we're going to get is an object containing all these properties. And since we're getting an object, we can use the power of ES6 destructuring to do some cool magic here, basically. So let me get rid of this one, or actually duplicate it, comment out this one, and so we can use destructuring to destructure the object that we get. Okay, and it works like this. So we use the curly braces, and then we simply create variable names for the properties in that object. So again, let's use add, multiply, and divide. So that are the names that we actually have on this exports object. So add, multiply, and divide. And these actually have to be the exact same name as in the original object. Okay. Now the thing that this will do is that basically it will create a variable called simply multiply. And so indeed, here is our result. And we can actually only import the ones that we want. So just say we only want add and multiply. Okay, and so we will only get access to these two instead of importing everything from the module. And this is quite a common pattern that you will see used in Node, and we will do that throughout the project as well. Okay, so in this video we talked about the wrapper function here. Then we talked about exporting and importing using module.exports and the exports shorthand. And now finally, just to finish, let's talk about caching very quickly. Okay, so let's create test module 3 here. And what I'm going to do here is to create a console.log. So basically some top level code inside this module. Hello from the module. Okay. And then I also want to export a function. Just one single function. And so I'm saying module.exports equals function without any arguments. One that will simply log to the console, log this beautiful text. Just some small emoji here to make it pop a little bit. Okay. So let's now require this test model. Test module 3. And I'm not saving it to any variable. Instead, I'm going to call the function right away without saving it to a variable. So we could, of course, do that. Then we would have the function in a variable, and we could then call it. But this is the exact same thing, because this will return this function that we defined. So this one here, right? It will return this because we're using module.exports. And then right away, we call this function here. Okay, and so actually, let's do that 3 times. And keeping in mind that we have caching in Node.js modules, what do you think will happen when we run this code? Okay, so let's run this and see what's going to happen. Here we have the result, hello from the module, and then 3 times log this beautiful text. So we have this logging here 3 times? Well, because we called the same function 3 times. But we have hello from the module only once, okay? And that is because of caching. So technically, this module was only loaded once. And so the code inside of it was also executed once only. And so that's why this line of code here, this logging, was only run once, okay? And so these other 2 loggings here, well, they came from cache. So they were stored somewhere in the node's process's cache. And once we called the function here for the second time, it was simply retrieved from there instead of loading the module again. Okay, so I'm sure that makes a lot of sense to you. And so that was our lecture actually. If you have any questions, you can of course as always post them to the Q&A and you will get help there. So that finishes this entire section. I know it was quite of a ride until we finally got to this point, so a lot of stuff to take in. And if you didn't correct everything 100%, don't worry all too much about it, because throughout the course, most of the stuff will become clear eventually. Okay? So don't worry, just keep moving on in the course, and I'll see you in the next section.